Hi guys, I guess confidence is what I have before I'm in full possession of all of the facts, and I really did think with this little HHO cell that I'd ring the capacitive component of it against an inductor and just establish the resonance, and that's what you'd normally do to establish a resonant frequency. But I have been looking at it at low frequencies. I've got a couple of signal generators, and the first one goes from about 1 Hertz to 1 megahertz, and I simply cannot find resonance with that signal generator. And I've tried a range of inductances, and always I get the same result. I get a pretty flat response, and that's because the Q of the circuit, little tank circuit, is so low. There's less than 100 picofarads of capacitance when the capacitor is dry, but as soon as you get it wet, so of course you've got a resistance across there, and it kills the Q, and it also creates other problems because it starts to look like a battery as well. So what I've done, I've moved on to another signal generator that goes up to 100 meg. It's not brilliant at 100 meg, but it goes up there. It's an old valve generator, or a valve signal generator, and I'll show you. But essentially, when I put the cell in water, it quenches the Q. So what I thought I would do is dry the cell off, dry the plates off, and remember these are 2 plates 100 millimeters square, and I'm working with a gap of 1 millimeter. And what I've decided to do is take a little inductor, about half a microhenry, something like that, and put that in parallel with the capacitor. All I want to do is just establish the capacitance. What I've done is I've taken the cell out of the housing, and I've also removed the bottom fixings and their washers. And the reason I've done that is when I dip this into the water, when the water stays across the washer and the threads, it influences the readings that I want to show you. It's maintaining approximately a 1 millimeter gap, but it'll be near enough for me to make the point that I want to make. On this green wire, of course, or green and white, is the thermocouple, but that's glued into place. It's not connected to the plate, it simply sits in the top of the water when the cell is immersed into the enclosure. And remember, I've got a meter of coax, and that's the RG58U coax. This coax goes off and feeds the HHO cell. This lead is from my RF signal generator, and you can see I've got the signal generator connected in parallel with this coil, and the coil is in parallel also with the feed to the cell, so everything's in parallel there. We'll connect the oscilloscope across there as well, and then the cell is out of the water. I've just put some little nylon spacers in there just to hold those two at the right distance apart, and now we'll go and look for resonance. So this is the signal from the signal generator. That's currently 21 megahertz, 22, 23, 24, 25, 26, and it looks like it's peaking around there. That's 30 megs. Oh, that's just over 30 megs there. Okay, so coming back down in frequency, you'd say that's peaking there, and that's just about 26 megahertz. Now remember, I've had to go to this frequency because the capacitance is so small that the Q is very, very small, and trying to measure the resonant frequency peak at low frequency is just not on. So what I want to show you now is I'm going to take that cell, that's the water, and I'm going to just put it in. I'll just try and dip one corner in, and I want you to see the oscilloscope at the same time. So you can see that signal, it's actually increasing. Okay, now that's an increase in capacitance. I'm just going to vary the frequency. Yeah, I'm going to have to change the gain on there. So that's introduced the cell a little bit. Now I'm just going to tweak the tuning. Okay, so that's about 19 megahertz. So it's lowered it, and that's you'd expect as the capacitance goes in. What I wanted to be able to do is just introduce this and tease it down and follow it, because when I get a lot of plating, well, that's a completely different result to what I was getting previously. I'm just adjusting the frequency and just seeing that peak is not very convincing, is it? And I don't like the way it's non-linear. I think that's a little glitch. Well, that's suggesting that that this is resonating with this coil. Okay, doesn't all fall apart. That's suggesting that is resonating at about 18.5 megahertz. So that's 16.5 megahertz, 18.5, 21. I can give you some idea. Well, as I said in that last little clip, I think that the high frequency signal generator of mine it's not sinusoidal up at these high frequencies, and occasionally it throws out some sproggies that confuse the issue a little bit for me. But you can see quite clearly there, we could get the cell to resonate against that little coil. But what I wanted you to see was by actually resonating the cell out of the water and then slowly introducing it, and if you like tracking the resonant frequency, so you can follow it. But earlier in the day I found if I tried to measure the resonant frequency with the cell immersed in water, I couldn't get a proper response at all. So it's almost as if something has changed through the day. I don't quite understand it, but as I say, at the end of it you could see that clearly we'd found resonance for that cell. I think for anybody trying to find the resonance of a very low capacitance cell at low frequency, it's going to be extremely difficult. And in looking around, I see everybody struggles, and it's really quite obvious why is the Q is so desperately low. Not fully sure where I'm going to go with it from here. That signal generator is it's going to be a very high impedance output, so it doesn't get a lot of drive capability. Whatever I do drive the cell with, it's got to have some capability, some low impedance capability. I just realised I've just been editing the video, and I realised that I've been banging on about Q, and you may not know what Q is, and it has some very complicated definitions, but I'll give you a mechanical analogy. If you think of Q as a measure of how sharply something is tuned, if we hold this rule on the edge of the table and we twang it, and we can say that's a high Q. If we now take this banana and twang it, that's a low Q. There's, this thing, you just cannot find the resonant frequency, whereas this, we can alter the resonant frequency, and that's a high Q, and it's getting higher. So high Q, lower Q, and that's about equivalent to a HHO cell. So with that, I say the best thing to do with it is say, well, I hope you enjoyed the video, guys, and thanks for watching. Bye bye. It's good.